In a distant future, humanity finally accomplishes something once believed impossible: the launch of the first deep space probe designed to leave the Milky Way. Sleek, metallic, and powered by engines fueled by exotic physics, the craft drifts beyond the galactic edge like a silver needle cutting through cosmic darkness. This moment is not merely scientific, it is cultural. Across human settlements on Mars, the Moon, Titan, and dozens of orbital colonies, enormous holographic displays project the live feed of the probe's journey. School children stare in awe. Scientists whisper excitedly over data streams, and entire cities pause as humanity collectively witnesses a milestone that surpasses even the first moon landing. For the first time in history, a human-made machine is escaping the galaxy. The probe continues silently into intergalactic space, its instruments sending back pristine data. Celebrations erupt across the colonies. Messages of pride and hope flood every communication network. And then, without warning, everything changes. The probe suddenly jolts, as if it has been punched by an unseen force. Engineers initially assume it must be a small impact or a stabilizer malfunction. But within moments, the situation turns catastrophic. The front of the probe begins to bend inward, crushed by something invisible and impossibly powerful. Panels warp. Support beams twist violently as if squeezed by a force far beyond anything it was built to withstand. Alarms blare across mission control rooms throughout the solar system as the craft's hull collapses in on itself. Live feeds show the metal folding like soft foil, structures tearing apart, engines imploding, and systems exploding in bursts of sparks. The signal degrades into static, then returns in a flicker just in time to reveal a tiny, dark object drifting through the remains. It is not an asteroid, not debris, and not another ship. It is something far smaller and far more terrifying. An object no bigger than a grain of sand has just passed through the billion-dollar spacecraft without slowing down, crushing it effortlessly in the process. The probe was destroyed by a primordial black hole, a microscopic remnant from the earliest moments of the universe. The feed goes silent, and humanity watches in stunned disbelief. This single moment reveals a chilling truth. An ancient, subatomic black hole, something that could be drifting through space even today, possesses enough gravitational force to rip apart a human spacecraft like paper. And then the narrative clarifies: though this scene is fictional, the science behind it is startlingly real. Primordial black holes may exist, born from the chaotic violence of the Big Bang, hidden throughout the cosmos and waiting to be discovered. While the story of Wanderlust I is fictional, the idea it illustrates is rooted in real physics. Tiny black holes, sometimes called primordial black holes, have long been considered impossible by many scientists. For decades, the only known way to create a black hole was through the death of a massive star. Stars 20 times more massive than our Sun, or even larger, burn through their nuclear fuel quickly. When their cores collapse under the immense pressure of gravity, the star explodes in a supernova, leaving behind a singularity, a black hole. These stellar black holes, formed from dying giants, are extreme by human standards, yet they follow a predictable pattern. Smaller stars, those under about 20 solar masses, do not collapse into black holes. Instead, they form neutron stars, ultra-dense objects made almost entirely of neutrons, or, if small enough, simply fade away without any dramatic explosion. The universe, it seemed, had rules that limited the sizes and formation of black holes. Yet, as our understanding of the cosmos grew, strange anomalies began to emerge. Observations revealed black holes far larger than could have formed from ordinary stars alone. Meanwhile, theoretical work suggested that the early universe, in the first moments after the Big Bang, was a chaotic, high-energy environment. Density was uneven, pressure was extreme, and matter was packed together in ways that defied common experience. In those fleeting fractions of a second, it became possible for regions of space to collapse under their own gravity without ever forming stars first. These primordial black holes could have formed with masses ranging from that of an atom to thousands or even millions of times the mass of our Sun. The very conditions of the early cosmos acted as a natural factory for black holes that didn't rely on stellar collapse at all. The concept of primordial black holes was first proposed in the 1960s by physicists like Yakov Zeldovich and Igor Novikov. They suggested that if density fluctuations in the infant universe were large enough, tiny but incredibly dense singularities could form, surviving long past the fiery birth of galaxies and stars. Some could have been massive enough to seed the supermassive black holes we now see at the centers of galaxies, while others could have remained minuscule, almost impossible to detect. These microscopic objects, often imagined as having the mass of an adult rhinoceros but smaller than a proton, are what some scientists call black hole rhinos. Despite their small size, the gravitational force they exert is extreme enough to crush anything unlucky enough to cross their path. Although the idea is compelling, primordial black holes face two major challenges. First, Stephen Hawking predicted that small black holes emit radiation now called Hawking radiation, and that over billions of years, this emission would cause them to evaporate completely. According to this theory, any tiny black holes from the early universe should have vanished long ago. Second, until recently, we had no observational evidence that such objects ever existed. Unlike the supermassive black holes anchoring galaxies, primordial black holes would not necessarily interact with nearby matter in noticeable ways. They could drift silently through the cosmos, invisible to even the most powerful telescopes, unless they collided with something unfortunate like a spacecraft, or hypothetically, a planet. Yet recent discoveries are beginning to change that perception. Observations from the James Webb Space Telescope, for instance, hint at black holes forming in the earliest galaxies, sometimes far from the usual stellar nurseries. These findings lend credence to the idea that black holes can indeed appear independently of stars, suggesting that primordial black holes may have existed, and perhaps some still do, quietly drifting in the shadows of our galaxy. If they survive, they could account for part of the universe's mysterious dark matter, the unseen mass that holds galaxies together. In other words, the invisible predators imagined in our fictional opening, the black hole, rhinos might not be purely imaginary after all. As our understanding of the universe deepened, astronomers discovered something far more astonishing: black holes far larger than any star could have produced. At the heart of nearly every large galaxy, including our own Milky Way, lurks a supermassive black hole, a gravitational monster millions or even billions of times more massive than the Sun. These titans dwarf stellar black holes, which form from the collapse of massive stars, and their very existence raised profound questions. How could something so enormous form so quickly in the universe's infancy when stars themselves were just beginning to emerge? Conventional theories of stellar collapse could not explain the rapid formation of these cosmic giants, especially those observed in galaxies less than 1 billion years after the Big Bang. Time, it seemed, was too short for a black hole born from a star to consume enough material to grow to such unimaginable size. The launch of the James Webb Space Telescope in December 2021 offered a revolutionary new window into these mysteries. By capturing light from the earliest galaxies, Webb allowed astronomers to see the universe as it existed mere hundreds of millions of years after the Big Bang. Tiny, faint red dots in the images revealed galaxies with fully formed supermassive black holes, many of which appeared far too early to have grown from ordinary stellar black holes through the slow process of accretion. The discovery shook the foundations of cosmology. The universe seemed capable of producing black holes without the usual prerequisite of stars These observations hinted at a radical possibility. Some of the supermassive black holes we observe today may have originated directly from the primordial chaos of the early cosmos, bypassing stars entirely. Further evidence emerged from galaxies with unusual chemical compositions. Certain early galaxies detected by Webb contained extremely low amounts of heavy elements, less than 1% of the oxygen levels we see in the Milky Way. These galaxies had not yet experienced multiple generations of star formation, meaning the black holes at their centers could not have formed from dying stars. Instead, they appeared to have formed in situ, collapsing directly from massive clouds of gas under extreme density and gravitational pressure. The implications were staggering. If supermassive black holes could appear fully formed in the early universe, smaller primordial black holes, or hypothetical black hole rhinos, could also have formed and survived across cosmic time, hiding in the outskirts of galaxies, completely invisible to our telescopes. The idea that these tiny black holes might still exist today has profound consequences. Unlike their massive cousins, small primordial black holes would be extremely difficult to detect. They could drift silently through the Milky Way, unnoticed by conventional observations, their presence inferred only through subtle gravitational effects or rare collisions with visible matter. Some scientists even speculate that such objects could contribute to the universe's enigmatic dark matter, the unseen mass that holds galaxies together and influences the motion of stars. In essence, the tiny black holes that our fictional probe encountered might not just be a story, they could be real. Ancient relics of the universe, lurking invisibly, waiting to reveal themselves in unexpected ways. The implications for space exploration are equally chilling. As humanity dreams of venturing beyond our galaxy, we may unknowingly traverse regions where these primordial black holes silently drift, potentially endangering spacecraft or even planetary colonies. Their mass is extreme relative to their size, meaning even a near miss could have catastrophic effects. Though speculative, the possibility forces us to reconsider our cosmic environment. The universe is not a uniform, empty void. It is filled with ancient relics of creation, silent predators shaped in the first moments of existence, that remind us just how little we truly know about the cosmos and the dangers that may lie ahead. To understand how such tiny yet immensely powerful objects could exist, we need to dive into the physics of black hole formation. A black hole, at its core, is a region where gravity has become so intense that nothing, not even light, can escape. In the present-day universe, this usually happens when a massive star exhausts its nuclear fuel and its core collapses under its own weight, forming a stellar black hole. But the earliest universe played by a very different set of rules. Within the first second after the Big Bang, the cosmos was an extreme high-energy soup of particles and radiation, with regions of vastly different densities. In these tiny pockets, matter was compressed to extraordinary degrees, and gravity could overpower all other forces acting on the particles. Under such conditions, even a small clump of matter could collapse directly into a black hole without ever forming a star first. These were the primordial black holes, ancient relics from the very birth of the cosmos. The size of these black holes could vary dramatically. Some could have masses thousands of times that of the Sun, while others might have been smaller than an atom, yet still as massive as a rhinoceros. Despite their minuscule size, their gravitational pull would be extraordinary, capable of distorting space-time in ways that would devastate any object that crossed their path. These black hole rhinos, as some astronomers imaginatively call them, are essentially invisible bullets speeding silently through the galaxy. Detecting them directly is nearly impossible because they do not emit light and do not necessarily interact with ordinary matter. Only when they collide with stars, planets, or spacecraft would their presence become violently apparent, exactly like the catastrophic scenario we imagine with Wanderlust 1. Even the smallest of these primordial black holes should have faced a slow death over billions of years due to a quantum process known as Hawking radiation, predicted by Stephen Hawking. This radiation causes black holes to emit energy and gradually shrink over incredibly long timescales. Tiny primordial black holes, some theories suggest, would have evaporated entirely by now. Yet recent research challenges this assumption. Some studies indicate that at very low masses, Hawking radiation may slow or even halt under certain conditions, allowing these black holes to survive far longer than previously thought. If this is true, there could still be a hidden population of microscopic black holes drifting silently at the edges of galaxies, or through the interstellar void, a cosmic minefield that humanity has yet to detect. The very existence of primordial black holes would have profound implications for our understanding of the universe. They could help explain the origins of supermassive black holes, which appear too massive, too early, and too quickly to have formed solely from stellar collapse. Tiny black holes, born in the primordial chaos, could act as seeds, consuming surrounding matter over billions of years to become the giants anchoring galaxies. Moreover, they could account for part of the mysterious dark matter, the unseen mass that exerts gravitational pull throughout the cosmos, yet emits no light. In essence, these tiny ancient objects may not only be remnants of the early universe, they could be fundamental pieces of its structure, silently shaping galaxies, star systems, and the very motion of the cosmos itself. Thinking about these primordial black holes is both awe-inspiring and terrifying. They remind us that the universe is far stranger and more dangerous than our everyday experience suggests. While humanity dreams of traveling to distant galaxies, we may encounter invisible objects that could tear apart our most sophisticated machines or destabilize entire star systems. They are a reminder that the cosmos is not an empty void. It is alive with ancient forces, shaped in the first fractions of a second after the Big Bang, hiding dangers that challenge even our most advanced science and imagination. The real breakthrough came with the launch of the James Webb Space Telescope. Launched on the 25th of December 2021 and operational in 2022, Webb offered astronomers an unprecedented view of the earliest galaxies, capturing light that had traveled for over 13 billion years. It revealed the universe as it existed when it was less than 1 billion years old, an era previously beyond the reach of our instruments. Among these distant, faint galaxies, Webb uncovered something extraordinary. Supermassive black holes already fully formed at the centers of galaxies that appeared chemically primitive, almost untouched by generations of star formation. Their very presence defied conventional expectations. According to standard models, there simply hadn't been enough time for black holes to grow so large by feeding on stars or gas. Something else, something far more ancient, had to be at work. These observations offered tantalizing support for the primordial black hole theory. If black holes could form directly from dense pockets of matter in the early universe, bypassing stars entirely, they could explain how such massive objects appeared so quickly. Webb's data revealed galaxies with extremely low levels of heavy elements, such as oxygen and carbon elements that typically accumulate after multiple generations of stellar birth and death. These unevolved galaxies implied that the supermassive black holes at their centers had not grown from earlier stars. Instead, they likely originated from the collapse of primordial matter itself. Essentially, these galaxies acted as cosmic time capsules, showing us black holes in their rawest form, created during the universe's infancy, long before conventional star-driven processes could operate. Among the discoveries, two particular cases stood out. In July 2025, NASA reported that Webb had observed two early disk galaxies seemingly in the process of colliding. Between them, at a location that was not the center of either galaxy, floated a supermassive black hole. It had not been ejected from either galaxy, nor was it tied to a third galaxy of its own. This enigmatic object suggested formation in situ, directly from a collapsing gas cloud without the intermediary of stellar evolution. Another object, known as QSO-1, resided in a surprisingly small galaxy with less than 1% of the oxygen present in our Milky Way. Spectral analysis confirmed its chemical youth. These galaxies had barely formed stars, yet already harbored massive black holes. These findings pointed to a universe where black holes could essentially appear if the right conditions, density, pressure, and primordial matter were present. The implications of these discoveries extend far beyond academic curiosity. If supermassive black holes can form directly from primordial matter, it increases the likelihood that smaller primordial black holes, our hypothetical black hole rhinos, also formed and survived. These tiny, ancient black holes could be scattered throughout galaxies, including our own, silently orbiting the Milky Way or lurking in the outer halo. Invisible to the naked eye and nearly impossible to detect with standard telescopes, they represent a hidden population of relics from the universe's birth. Some scientists even speculate that such objects could account for a portion of dark matter, the mysterious, invisible substance that exerts gravitational influence across the cosmos. The very fabric of our galaxy and the forces governing its structure may be shaped in part by these elusive primordial objects. Thinking about these ancient black holes is both thrilling and unsettling. As humanity dreams of venturing into deep space, leaving the Milky Way to explore neighboring galaxies, the possibility arises that we may traverse regions teeming with tiny, invisible black holes. Space, often imagined as a vast and empty void, could instead be a hidden minefield where these ancient objects drift silently, carrying masses far beyond what their size would suggest. The discoveries made by Webb are a reminder that the universe is not only stranger than we imagine, it is stranger than we can imagine, populated with forces that defy intuition, shaped by conditions in the first moments after the Big Bang, and waiting to challenge every assumption humanity makes about the cosmos. The existence of tiny primordial black holes, those black hole rhinos, raises a chilling possibility. Space might be far more perilous than we imagine. Unlike the supermassive black holes anchoring galaxies, these miniature titans are virtually invisible, drifting silently through interstellar space, carrying immense gravitational pull relative to their size. Their trajectories would be unpredictable, and they could easily pass through stars, planets, or spacecraft without warning. Imagine a probe like Wanderlust 1, our brave intergalactic explorer hurtling toward Andromeda. A collision with even one of these tiny black holes could spell instant destruction, crumpling its metallic frame, scrambling its systems, and sending debris spinning into the void. While this scenario is fictional, it vividly illustrates the real hazards that could exist in the cosmos. Even the most carefully charted course through space might intersect with one of these ancient relics, whose mere presence could obliterate human technology. Detecting these black holes is extraordinarily difficult. Unlike typical stellar remnants, they do not emit light or interact strongly with ordinary matter unless there is a direct collision. They lack the bright accretion disks that make other black holes visible, and their gravitational influence over nearby stars is subtle due to their small size. Astronomers would need extremely sensitive instruments or indirect observations to identify them, perhaps noticing slight gravitational lensing of distant stars or peculiar perturbations in orbital patterns of planets or asteroids. Yet even these techniques are only effective for a limited range of mass and proximity. For black holes the size of a rhino, they could traverse entire light years unnoticed, lurking silently in the galactic halo or interstellar void. This hidden population could be vast, numbering in the millions, forming a kind of invisible cosmic minefield through which any intergalactic traveler must navigate. The potential implications extend far beyond isolated incidents. Tiny primordial black holes could help explain the composition and behavior of dark matter, the unseen mass that dominates galaxies and governs their rotation curves. If even a fraction of dark matter consists of these black hole relics, it would mean that the universe is filled with countless small, incredibly dense objects quietly influencing galactic structure. From a human perspective, this is both awe-inspiring and terrifying. Our understanding of the cosmos, of empty space, may be incomplete. The regions we perceive as voids could be swarming with ancient, high-density objects formed in the first fractions of a second after the Big Bang. Any mission venturing into deep space, whether probes, spacecraft, or even future interstellar colonies, would need to account for this invisible danger, navigating a universe that is far more alive and unpredictable than our familiar night sky suggests. Even as scientists continue to study the early universe, each new discovery adds weight to the idea that primordial black holes may not only have existed, they may still exist today. Observations of supermassive black holes in surprisingly young galaxies, combined with recent research suggesting that Hawking radiation could slow or halt in tiny black holes, imply that these cosmic relics might have survived billions of years of evolution. The universe, then, is not simply a stage for visible stars, planets, and galaxies. It is a vast and intricate landscape where tiny, ancient forces continue to shape reality. The idea that one of these minute, deadly objects could collide with a spacecraft or disturb a planetary system is unsettling, but it also underscores the dynamic and interconnected nature of the cosmos. Our imagination, aided by fiction like the Wanderlust 1 scenario, allows us to grasp these invisible threats, blending scientific possibility with dramatic storytelling to explore the universe in ways that pure data alone cannot convey. Ultimately, tiny primordial black holes remind us of both the fragility and resilience of exploration. While they present real hazards, they also offer invaluable clues about the universe's origins, its earliest moments, and the forces that continue to govern its evolution. Each hypothetical collision, each carefully plotted trajectory, and each telescope observation is a step toward understanding a cosmos far stranger than human experience alone can reveal. The same forces that could destroy a probe are also the ones that help us trace the universe back to its primordial beginnings, revealing a story written in gravity, density, and time, one that we are only beginning to read. As we step back from the vast cosmic stage, the story of tiny primordial black holes leaves us with a profound sense of awe and caution. These invisible relics, born in the universe's earliest moments, challenge our understanding of space, time, and gravity. They could be silently orbiting galaxies, shaping the structure of the cosmos, and even contributing to the enigmatic dark matter that binds the universe together. While their existence remains largely hypothetical, recent discoveries from supermassive black holes and chemically primitive galaxies to the refined predictions of Hawking radiation suggest that these ancient objects might not be mere theoretical curiosities. They could be real, and their influence might be woven into the very fabric of reality around us. The hypothetical encounter of a spacecraft like Wanderlust 1 serves as a dramatic reminder of the hidden dangers that may await humanity as we venture deeper into space. It's a universe where not everything is visible, predictable, or safe, where even empty stretches of the cosmos could harbor threats the size of a rhino yet heavier than mountains. And yet, it is precisely this uncertainty, this hidden dynamism that makes the universe so fascinating. Every faint dot of light, every anomaly detected by telescopes like James Webb is an invitation to explore, question, and push the boundaries of human knowledge. The cosmos is not a passive backdrop, it is a living, evolving entity filled with forces and objects that defy intuition. And in understanding them, we uncover the history and future of everything around us. Ultimately, the story of primordial black holes is a tale of cosmic mystery, scientific detective work, and the thrill of discovery. It reminds us that the universe is far stranger than we often imagine, full of secrets that challenge our assumptions and ignite our curiosity. Whether they are out there lurking silently, shaping galaxies, or simply inspiring our imaginations, these tiny black holes teach us that space is a realm of endless wonder and danger. And as humanity prepares for interstellar journeys, probing the depths of galaxies and the edges of the Milky Way, the lesson is clear. The universe is full of surprises, and our quest to understand it is just beginning. So as we gaze up at the stars and dream of venturing beyond our galaxy, let curiosity guide us, caution sharpen us, and imagination carry us. The invisible, the ancient, and the unimaginable are out there, waiting. And perhaps one day, humanity will witness firsthand the delicate dance of these primordial forces, revealing a cosmos far more alive, intricate, and mysterious than we have ever dared to imagine.